Good day. So now I'm going to answer the questions 3, 4, and 5. So for number 3, given the truth table below, write the space at the rightmost, the simplest equation. Implement the circuit in logism. So what I did was to construct the K-map in the Excel. In Excel. So following that truth table, uh, as we can observe in the truth table, there are only 4 inputs. So all of those inputs were the same, and the only difference is the output. So the output in that truth table, uh, it has 7 outputs. So A, B, C, D, E, F, and G. So what I did was isolate each output. So for A, this is the K-map, and this is our simplified equation. For B, this is the K-map. For C, D, E, F, and G. So now we're going to implement it into the logism. So as you can see here, for A, the simplified equation is A plus C plus BD plus B prime D prime. So now, because we are going to use the universal gates, the NOR and NOT, for this activity. So instead of using a NOT gate, we're going to use a AND gate uh, for us to have a a complement of our input. So we use NAND gate. So now we're going to construct the circuit. So for A, this is the inputs and connected to a NAND gate so that we can have the inverse. So now, going to add some gates. As you can see here, A and C does not need another gates, and they were directly connected to a OR gate. So here we're going to connect NAND gates. This circuit is considered to be a AND gate. So we connect B and D. B, E. And then now we're going to use the B complement and D complement. So for B complement, now we're going to connect it to an OR gate. But if we use the uh, NAND and NOR gate, we can construct it like this. So an OR gate. Now we already constructed a OR gate by the use of NOR gates. So we connect it A, C, for C, the BD, we should name it. This is BD, and this is B complement. So following this came up, we can check it. So if our input is 0, 0, our output must be 1. So 1. When our input is 0, 0, 0, 1, change it, 0, 0, 0, 1, our output must be 0. So moving on, for the next output B, reconstruct again. On to letter C. So for D, and now for E. For F, now we're going with F. So lastly, for G. So So that's for question number 3. So in A, the output B, C, D, E, F, and G. Now moving on to the fourth, number 4 question. So given the function f, wxyz is equals to the summation of 1, 3, 4, 6, 8, 9, 10, 11, 13, and 15. So what we did here is convert each of those decimal numbers into binary. So for example, and we plot it in our K-map. So for example here, we have 1. So 1 can be represented in binary as 0, 0, 0, 1. So here we put 1. And then for 3, it can be represented by 0, 0, 1, 1. So we put 1 again here. And 15, for 15, its binary form is equal to 1, 1, 1, 1. So 4 ones. So that's the binary. So following that, we gathered a simplified equation of wxz prime plus wz plus x prime z plus xz prime. So now we're going to implement it here in Logism. So make a name first. X. So that's our simplified equation. Then again for our input, we put NAND gate so we can have a inverter. So we now going to construct the gates, and we again going to use the universal gates. So as you can see, if our number is 0, 0, 0, or convert it into decimal, that is 0. So if we put now 00001 and it represents 1, so our is 1. So if we try to make it a 3, so 0011 still 1. And then in our for example 15, so our the binary representation of 15 is 4 ones. So 4 ones is 1. That's it. And again, we use SOP in that matter. So in question number 5, implement the following K-map in Logism using SOP. So as we can see here, it's 0, 0. But if we're the highlighted numbers were zeros. But if we're going to use SOP, we can assume that those black spaces were ones. And if we're going to use SOP, those ones is what we're going to use. So moving back here in our generated K-map from question number 4, we can see that it is the same as this. It is the same as this K-map, this table. So with that said, we can say that question number 4 and 5 were the same. So we're just going to again gather an equation of wxz prime plus wz plus x prime z plus xz prime. So answering that number 5 question, we can just copy the steps in question number 4. So that's it. Thank you.